Welcome to the Kibana tutorial series. My name is Tim and today we are talking about terms and significant terms in Kibana. We will have a look at how terms work in Elasticsearch and therefore Kibana, and how a terms aggregation and the significant terms aggregation work. To follow this tutorial, you should be familiar with how aggregations work in Kibana. If you are not familiar with how aggregations work in Kibana, you can find a tutorial on that in the playlist of Kibana tutorials on my channel. Let's assume we have these two documents which contain of an ID field and a title field, and we insert them into Elasticsearch. Elasticsearch then creates a so-called inverted index for the title field. Therefore it tokenizes the value in the so-called terms by splitting the strings up at word boundaries. The inverted index then stores each term and a reference to which documents contained that term. So in our example, the inverted index looks as follows. We would have the term the in there, and it would have a reference to the ID1 and ID2 because both of the documents contain the word. Elasticsearch builds up this inverted index so that it can quickly look up search results. So if you later search for Galaxy, it just needs to look up in the inverted index for Galaxy and it will directly see, okay, it's one document containing Galaxy with the ID1 and it can just return you that document. After tokenizing the string into several terms, Elasticsearch can also transform or filter these terms. For example, by default, Elasticsearch will transform all terms into lowercase, as you can see in the video. You can configure Elasticsearch to also throw out some of the terms, for example stop words. A terms aggregation is a bucket aggregation. So it's responsible for creating several buckets and sort documents into these buckets. Therefore, it just looks at the inverted index and create one bucket per term and sort the documents that contain this term into these buckets. So for our example, it would look as follows. You would get a bucket for each of the terms, like the, hitchhiker's, guide, and so on, and all the documents that contained that term would be in this bucket. The terms aggregation has some configuration parameters. One parameter is the size. The size specifies how many buckets it should return. Also, since it doesn't return all of the terms, if you limit the size, it must know which of the terms it should return as buckets. So that's specified by the order by configuration parameter. For example, you can configure that Elasticsearch should return the buckets that have the most documents in them. So it will basically return all the terms that occur in the most documents, or the least documents if you set the sorting order to descending. Besides the count, you could specify any other matrix aggregation. Elasticsearch would then use this matrix aggregation to calculate a value for each bucket and then return the buckets that have the highest or lowest value, depending on whether you set the sort order to ascending or descending. So now we know what the terms aggregation does. Now let's have a look at the significant terms aggregation. The significant terms aggregation tries to find terms that are significant for a specific group of documents within the whole set. Therefore, it needs to work on two sets. You need the so-called background set, and you need a foreground set. The foreground set is this set for which it tries to find significant terms. The background set is the terms against which it tries to find these significant terms. By default, the background set are all documents in the queried indexes, and the foreground set are the currently shown documents, which is the documents that you either searched for, that you filtered for, or that are just selected by the current date range. Elasticsearch now looks at all the documents within the foreground set and try to find terms that are significant to these documents within the set, in contrast to the document outside of the set but within the background set. Let's look at an example. Let's assume we are logging requests to our server into Elasticsearch. Each document have a field containing the user agent of the visitor. In this example, we only having visitors from Chrome, Firefox and Internet Explorer. We now need to define a foreground set, because without the foreground set, the significant terms aggregation doesn't work. So let's search for all the requests that took longer than 2 seconds. These documents with a response time over 2 seconds are now the foreground set and are indicated by a green circle in this example. If we would create a regular terms aggregation on this foreground set, one of the largest buckets would be Chrome, because it has the most documents within this bucket. But it's not significant for the foreground set, because also in the background set the most requests are coming from Chrome. The top bucket in a significant terms aggregation, however, would be the one for Internet Explorer, because Internet Explorer has a significant higher occurrence in this foreground set than it has in the background set. That way you can use the significant terms aggregation for detecting anomaly within a specific foreground set. When using Kibana, the background set will always contain all the documents in the queried indexes. When you are writing a known application communicating with Elasticsearch directly, you can also change what the background set should be. If you are creating a significant terms aggregation and don't get any buckets as a result, your foreground set might be the same as your background set, meaning you haven't limited your foreground set, you haven't searched for anything, or haven't selected a time range that includes all document within your data. Another reason could be that the distribution of terms within your foreground set is really exactly the same like within the background set. In that case, there just isn't anything significant to the foreground set. For some use cases, it might be problematic that Elasticsearch splits up your values into several terms. Let's assume you have documents containing client information within Elasticsearch. Now you want to see where from most of your clients are. You do a terms aggregation on the city field of your client data, and what you will get is a bucket for new, a bucket for sun, a bucket for south, a bucket for north, and so on. Because a city name like New York is splitted up into two terms, New and York. And so the bucket aggregation won't return the whole city name, but the single terms of the city name. Another common problem would be storing URLs into Elasticsearch. If you do now a bucket aggregation on the URL field, you will get buckets like HTTPS, HTTP, and so on. That's most likely not what you would like to see. You would most likely have a bucket for each URL actually stored into Elasticsearch. This problem occurs when you are doing a terms aggregation on an analyzed field. Kibana will also warn you about this by printing analyzed field above the field name that you selected. You can solve this problem by telling Kibana within the mapping for your index that you don't want some of the fields to be analyzed by Kibana. From Elasticsearch 5 onwards, and therefore Kibana 5 onwards, there are two different types of fields. There's a text field, which behaves like explained, by splitting up each string value into several terms, and there's a keyword type, which will cause Elasticsearch not to split up a value into terms, but store the whole field value as one term. Prior to Elasticsearch 5, both of these types were called string, but there was an additional information whether this field should be analyzed or not analyzed. Also an additional information, from Elasticsearch 5 onwards, by default you won't be able to do a terms aggregation on a text field, meaning a field that has split it up into terms. You will need to set field data true inside the mapping for this field, so that Elasticsearch will be able to do a terms aggregation on that field. If you are using the default mapping in Elasticsearch 5, Elasticsearch will automatically create a keyword field for each regular text field that you insert. So, if you are in Kibana, try looking for a field with the same name but ending in .keyword, which might hold the value that you are looking for, but in an unanalyzed manner. Prior to Elasticsearch 5, if you have inserted your data using Logstash, there might be a field called .raw in the end that will contain the same not analyzed value. I hope this tutorial helped you understand terms in Elasticsearch and Kibana, and helped you understand how you can use the terms and significant terms aggregation to get an insight into your data. It also hopefully helped you understanding why your terms aggregation may return strange values, or why your significant terms aggregation doesn't return anything at all. If you want to learn more about Kibana, have a look at my blog or other videos within this tutorial series. See you in the next video.